Malaysia has a population of 32.7 million people. Based on that value, 3.8% of them living their life with extremely poor condition. Even though the percentage of poor people in Malaysia is low, the gap between living condition in the urban areas and rural areas are very high. It is reported that approximately 71.3% of Malaysian population are settled in urban area, whereas 28.7% live in rural area. People who live in rural area are most likely to have a big problem when come to electricity supply. Hence, this problem affect their daily life in every aspect. Due to high cost of distribution and associated transmission loss in a grid power supply in rural area, it seemed not economic. Based on that, the off-grid electricity which can be generated by the renewable source provided the opportunity to expand the capacity of rural electrification and has the advantages as a cost-effective strategy and reliable sources. Hydropower is one of the most cost-effective when it comes to renewable energy. By considering the annual rainfall in ecosystem in Malaysia, hydropower can be considered as most appropriate renewable resource for rural electrification. The hydropower technology is electricity using the energy from moving water flow through a turbine, spinning it and cause turn to active the generator to produce electricity. The water source are mainly from river, streams and tides. It can be classified 6 category, which is large hydro, medium hydro, small hydro, mini hydro, micro hydro, and lastly pico hydro. As in this project, pico hydro was be focused. Okay, the pico hydro is hydroelectric system which can produce a maximum output of 5 kilowatt. These systems are useful in rural area that require only a small amount of electricity, such as lighting and charging smartphone. The paper produced the design, develop a portable Pelton turbine prototype. The Pelton hydro generator energy system need to be studied, designed, and the prototype will be tested to determine the feasibility of the system as the renewable energy source. The prototype of the system will consist of DC motor generator, battery charger, controller, battery supply, and the load. The DC motor is optimized when there is high pressure water flow intensity, resulting in the greater power output. A feedback system that operates as a device that collects data on energy and will energy release in watt will be read and displayed by the IoT platform. The use of the IoT make it easier for some daily activities to be done more effectively. It's aimed to send the data to the center to oversee project operation. Thus, this concept, in accordance with monitoring individual consumption as well as production process and their use, for example, solar system, windmills, and water management. Here we demonstrate the concept of smart energy harvesting using portable Pelton turbine and the design of basic hydroelectric system. To visualize the prototype of this small generator, we use the SolidWorks to draw and can be modeling in 3D graphics. This 3D drawing can help so that the proposed prototype can be computerized visualized. Therefore, any shortcomings can be corrected without incurring excessive cost. The proposed design can be seen as shown in figure left. For the monitoring system, it starts when ESP32 has been connected to the Wi-Fi. When the application has initiated on ESP32 Wi-Fi module, it will establish the internet. If there is an error, it will send a message back to ESP32. The input of INA 219 will send all data and generate the information via serial communication principle. Then all the data will be saved and sent to the KN platform to monitor the reading of all input. This project also will be equipped with manual interface to show the value of RPM of the DC motor. This can be seen from the LCD interface. Figures show the arrangement of the hardware in this prototype. The main controller consists of item 1 until 9. The battery also placed in the same box with the Node MCU ESP32 and the Arduino board. In actual situation, the controller board will be placed within the area which safe from any water splash, from heat and also the physical damage. This is to ensure a minimum maintenance is required on this controller board. The wiring will be connected from the DC motor output to the controller board. Next figure shows the complete assembly of the proposed prototype in this study. This is before attachment the water pressure at the input inlet on the top of the turbine Pelton housing. This container to make sure full force from water flow can enter and push energy to the turbine. This will make the turbine can be rotated more rapidly and maximum output can be obtained. The inlet from water tap is connected to the turbine inlet housing. The output voltage generated from the Pelton turbine can be monitored in the real time and data can be extracted directly from the platform for the analysis purpose. The raw data that were extracted is in CSV file. For easier to user, the dashboard in KN can be customized according to user desire. Figure left, upper and bottom shows the dashboard display the voltage generated, charging current in milliampere and power in watt unit. Here we can see that the dashboard shows 3 parameter display. However, the input for this display can be increased according to the sensor use. The extension input can be added, such as remote control sensors, actuators, and more for single board computers, microcontrollers, and other hardware connected to the Internet of Things platform. With this data online, user can see the status of the system installed in different places that have internet access. This will make it easier for the user to monitor the system without going to the install area. This can provide time and energy saving, especially when periodic monitoring is required. Data in KN dashboard also can be visualized in terms of graphic view. According to the figure, the y-axis represents the parameters which is in the project is voltage, current, and power. For the x-axis, it represents the data in time, which can be set the real-time monitoring minute, hours, day, weekly, and months. Data in KN platform will update every 15 seconds automatically. As a conclusion, the project of smart energy harvesting using portable Pelton turbine with IoT data feedback for a rural area application has been done successfully designed and tested. The system has been developed by integrating features of entire hardware and software use. In addition, the hardware and software architecture of the system is designed to improve previous system present. Node MCU ESP32 that has been used in the system is one of the tiny modern processors that can control the operation for collecting data from the sensor used. The KN IoT platform is used as the platform to gather the data from the Node MCU ESP32, and the data were presented in the platform are friendly use to users. The objective that we set in the beginning of this project was successfully achieved. As an improvement to this project, there are some features work that can be improved. For example, a new larger capacity for the battery. The current battery used as the storage is not enough to act as backup supply for a long period. So the larger capacity of the battery can help to solve this problem. Next, a large diameter type of flow sensor. Current flow sensors that were used were not suitable as it is small in diameter, thus decreasing the pressure of the water and the amount of the water flow are lower. So the larger diameter size for flow sensor will be great as it will not affect both pressure and flow of the water. Lastly, a proper piping for water supply can be used to ensure that sustainability and the renewable energy aspect were used in this project. The proper piping for the pipeline need to be built in order to get the maximized water flow and pressure.